Oh man, this is exciting. Negative exponents. All right, let's see if we can figure this out. Let's go from what we know to what's new. All right, and we can build on that from there. So let's start with something just like 5. Let's say 5 to the third. Now if I have 5 to the third, I can write that in expanded form, which is 5 times 5 times 5. And then I can write it in standard form, which would be 5 times 5, which is 25, times 5, which is 125. All right, so let's progressively move that closer to 0 as an exponent. So what about 5 to the second? So if I do 5 to the second, now I've got 5 times 5, and now I've got 25. What happened between these two? Right? 5 to the third, 5 to the second. What did happen was this: we divided by 5. So that dividing by 5 moved every one of these down one factor. So let's divide by 5 again. So 5 to the second divided by 5 to the first gives us 5 to the first. 5 to the first, the factors of 5 to the first are 5. And the value of 5 is 5. Let's just make note here. So let's say this is expanded form. This is standard form. And this is exponential form. And then let's write across the top forms, just because I'm feeling it. Forms. Hope that's even in the frame. All right, so now we're here. Let's divide by 5 again. All right, so when we divide by 5, we're going to have 5 to the first divided by 5 to the first. It's going to give us 5 to the 0, because that looks like this. 5 to the first divided by 5 to the first is the same as 5, 1 minus 1. Right? Going back to how we divide monomials, and that gives us 5 to the 0. Well, let's figure out what that is. So 5 to the 0 is what? What's 5 divided by 5? Well, it's 1. So in expanded form, it's 1. In standard form, it's 1. Isn't it in expanded form? No, I think I have the expanded form wrong. Let's change the expanded form so it looks the way we want it to look. 5 to the first over 5 to the first. 5 divided by 5. I'm even going to take the firsts off there. Right? There, that looks good. So we got 5 divided by 5, which is 1. Now let's go down another level. Divide by 5. Okay, so now I've got 5 to the 0 divided by 5 to the first. Now 5 to the 0 divided by 5 to the first rewrites as 5, 0 minus 1. 0 minus 1 is negative 1, which means our next step down is 5 to the negative first. Now here's the twist. Let's rewrite this in standard form, or in expanded form, which should look like 5 to the 0 is worth 1. 5 to the first is worth 5. Now we're here. So 5 to the negative 1, let me leave that there for a second. 5 to the negative 1 is equivalent to 1/5, which is 1/5, or 5 to the first. Let's divide by 5 again. So now I have 5 to the negative 2, which looks like 1 over 5 times 5, which looks like 1 over 25. You're seeing kind of a pattern here now. 5 to the negative 3 is 1 over 5 times 5 times 5, which is 1 over 125. Okay, when we look at this, it's a lot of numbers. Frankly, it's a lot of 5s. So let's see if we can define negative exponents real quick here. Negative exponents, therefore, are the reciprocal of positive exponents. The reciprocal of positive exponents. Let's look at some examples. So here's my first example, 3 to the negative fifth. Now what we want is we want the reciprocal of this exponent. So this would not be 3 to the negative fifth. We can also represent that as 1 over 3 to the positive fifth. This one, a to the negative third, we can represent that as 1 over a to the positive third. 8 to the second. All right, so that's 1 over 8 to the second. So now we're going the other direction. So that can also be represented as 8 to the negative second. And 1 over 36. Now here's where we got to take another step. So is there some number multiplied by itself that will give us 36? Good. So we can rewrite this as 1 over 6 times 6, 1 over 6 squared, which then becomes 6 to the negative 2. Let's apply the negative exponents now. So now we're going to try to multiply and divide with these monomials that have negative exponents. What we talked about in the review was those laws of the exponents still apply here, just we're using an integer that is negative as opposed to just whole numbers which are positive. So in the first example here we have 3 to the ninth times 3 to the negative fourth. So let's just rewrite that with our simple exponential expression, which is 9 plus negative 4. No, 9 plus negative 4. All right, 9 plus negative 4, we have 9 positives, 4 negatives. When those crash into each other, 4 of those negatives cancel out 4 of those positives, leaving us 5 positives, which is then 3 to the fifth. Now, do you need proof? Let's do some proof of this. And the proof of this is this. If I look at 3 to the ninth, that gives me 3 times 3 times 3 times 3 times 3 times 3. That's 6 of them. Times 3 times 3 times 3. There's 3 to the ninth over, and this says 3 to the negative fourth. Now 3 to the negative fourth, don't forget, is 1 over 3 to the fourth. So for multiplying these together, that gives me 3 times 3 times 3 times 3. 3 times 3 times 3 times 3 in my denominator. Now that numerator-denominator relationship is great when we have similar numbers, because then those numbers become 1. 3 divided by 3 is 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 1. And look what we're left. 1, 2, 3, 4, 5. 3 to the fifth. Okay? Sticking with that simple integer expression that you can create for the exponents is the key, especially for these. Now let's look at this one. We've got m to the negative second divided by m to the negative fifth. All right, so let's just write it as an exponential expression here, and we're going to describe that as m to the negative second minus negative 5. Now, this is critical. This negative sign says I'm the opposite of 5. This minus sign has to be here, okay? The minus sign is not created from that negative. The minus is here. Now, if you remember back to last year, the opposite of an opposite is the positive. So this rewrites as m negative 2 plus 5, or m raised to the third. Okay? This little sentence there that you write will be the difference in success and failure. Make sure you write it out, and then make sure you're following your rules for integer operations. Let's try this one. I've got x 9 minus negative 3. Again, that negative sign is here, and the subtraction has to happen. We go back to the laws of exponents. Dividing exponents means we subtract. Multiplying exponents means we add. So now we've got 9 and the opposite of 3, which rewrites as x 9 plus 3 or x to the 12th. Vocab now. So vocab, we have negatory, negative exponents, right, which are the reciprocal of positive exponents. So that means that 3 to the negative 3 is equal to 1 over 3 to the third. Like those are the same things. Probably another word that's sort of important in this lesson is remembering the idea of reciprocal. Reciprocal, and I'm going to give you like the standard definition, and the reciprocal is any number that when multiplied by a number, BER, is 1. Now some people just say the flip or the reverse or stuff like that. But the truth about a reciprocal is any number that when you multiply it by another number, it becomes 1. So if we look at something like 7, if we multiply 7 times 1/7, we get 7 over 7, which is 1. That makes that the reciprocal. If I have 2/3 and multiply that by 3/2, I get 6 over 6, which is 1, which means that is the reciprocal of 2/3. Okay, good luck.